If you are starting a vertical farm and don't know where to begin or which technology would suit your needs, then reach out to the experts at Cultivated. As indoor farm brokers, they help connect you to the right technology and ensure your project is successful. Best of all, their service is free because they work on behalf of their partners. Visit cultivated.com to learn more. And that's spelled cultivatd.com, or click the link in the show notes.
It's mainly about looking at problems and finding sort of an unthought of way to solve a problem that hasn't been thought of before, but sort of starting from this problem perspective. And that, this invention that we call digital electricity really came way back from that first business where we were working with the first battery. When they came out at that time, lithium-ion batteries were exotically expensive and dangerous. They were volatile.
Welcome to the Vertical Farming Podcast, weekly conversations with fascinating CEOs, founders, and AgTech visionaries. Join us every week as we dive deep into the world of vertical farming with your host, Harry Duran.
Vertical Farming Podcast Season 5, welcome back. First-time listeners, you are in the right place if you're looking for a show where we interview fascinating CEOs and founders of the leading vertical farming companies from around the world. I'm your host, Harry Duran. In case you missed last week's guest, we had Max Loso on. He's the CEO of Agrelution. Max has a vision for bringing the revolutionary concept of CEA to every home and to allow everyone to grow their own nutritious plants. And we had a great discussion about the work he and his co-founder have done to develop his personal vertical farming system. So please check that out if you haven't already. Hey, it's Harry. I'm dropping in for a quick reminder that Indoor AgTech returns to Brooklyn, New York on June 23rd to 24th. And it's a gathering of the world's leading growers, retailers, investors, seed companies, and technology providers to meet, network, and cultivate, pun intended, new commercial relationships. Key themes covered during the 2 days will be regenerating cities, tackling labor shortages, reducing costs and energy usage, plant science and seed optimization, beyond leafy greens, finance and investment, scalability and profitability, communicating with the consumer, and collaboration and partnership. It's going to be a jam-packed 2 days of content and connection. Can't wait to see you all there. IndoorAgTechNYC.com, and let them know Harry sent you. This week, we have a fascinating discussion with Stephen Eaves, the CEO and founder of VoltServer. I was really fascinated when I saw them at Indoor AgCon in Vegas, and I was grateful for the opportunity to have a deeper dive with Stephen about the concept of digital electricity. Stephen has over 20 years of experience in the energy industry and has a passion for doing things that have never been done before. He's an expert in battery management, power electronics, and energy infrastructure, and has 15 patents issued or pending related to energy storage and power conversion. In this episode, we talk about the origin story of VoltServer and the technology behind digital electricity. He shares his thoughts on where this can benefit vertical farming and what the future holds for both industries and high-tech power distribution. Really fascinating stuff. Don't forget, if you enjoyed this episode or past episodes, I'd love it if you leave a rating and a review at ratethispodcast.com/VFB. I'd love to read yours out next. Okay, let's jump into this conversation with Stephen. So Stephen Eaves, CEO and founder at VoltServer. Thank you for joining me on the Vertical Farming Podcast.
Thank you.
Where are you calling in from? Where's home?
East Greenwich, Rhode Island is where the office is, just outside of Providence, Rhode Island.
Okay. Is that has that been home for you for a while? Are you originally from there?
Yeah, been in Rhode Island about 25 years.
Okay.
Yeah, it's just a very pretty area.
And what's a little known fact about the area you're in that most people who don't live there wouldn't know about?
Well, let's see. Everybody knows it's the setting for Family Guy. That's what it's famous for.
Yeah.
Little known facts. Well, let's see that the state food is calamari.
Oh, okay. Didn't know that. But how are you? You enjoy the change of seasons there?
It's just about right for me. It's got to change. It doesn't get too cold or too hot. I mean, it does get pretty cold and rainy certain part of the year, but yeah, I like it. It's definitely a nice mix.
So I first heard about or saw VoltServer mentioned at Indoor AgCon. It was my first vertical farming conference that I attended in Las Vegas earlier this year. And I believe you guys had a booth there, and then I connected with your brother, and I think he was on stage. He spoke at one of the sessions as well. So it was an introduction to some of the interesting things you were doing. And from what I've heard, the feedback that you got at the conference was pretty positive.
Yeah, it was great. It was off the hook. It was a really good idea to place it with the food business people too,
Yeah.
the Food Buyers Association.
And was that the first conference where you were displaying or you had a booth set up?
We've been in some of the cannabis conferences earlier, which we saw as, it was really an initial market for all this stuff where, the customers have higher margin levels and things like that. But we've always believed that the food industry was where the long game was in the business.
So talk to me a little bit about your background for folks that don't know you. I know you have a background in engineering, and that's what you studied, and that was part of your earlier businesses as well. So maybe just wind the clock a little bit before we get into the origins of VoltServer. But have you always been fascinated with electrical engineering as a passion?
Yeah, I've focused around the energy space probably for the last 25 years through a series of startups. So this is my third startup business. And the previous one was a lithium ion battery company for industrial batteries. And then before that was it's a small company that was sort of a boutique company for energy management and controls like fuel cells and advanced batteries and things like that.
Has this always, since graduating from college, has this always been a passion for you, just in terms of like the energy space? And obviously we're working with lithium and now with the work you're doing at VoltServer, just looking for different solutions for some of the challenges and problems we face as a society when it comes to all the energy we do consume on a daily basis?
Yeah, I think that's what it is. I mean, it's really sort of maybe not even a passion and obsession, to do things that are new and that have impact. And energy, it just happens that energy is so foundational to everything. So working in that field is very impactful. So I just sort of settled into that naturally. As folks want to work on things that have some importance, they spend their time on. So I felt like it was a really good area to spend my time in.
What were some of the learnings from some of those earlier companies, the lithium ion industry? And I imagine there was a lot of on-the-job learnings as well as you were discovering the ins and outs of that industry. But I'm just curious, what were some of your takeaways from those endeavors?
Some of them were positive and some of them not so much, a lot of early learning. I worked with my wife in the first business and she helped a lot for establishing basic things in business like quality management. And, right away, we got involved with very high level projects in that first business, like satellites and military projects and things like that. And we were just coming out of the basement as a business and managing quality, connecting with these big sort of institutional companies that run programs it was pretty fast acceleration for us. Yeah. A lot of sleepless nights. Yeah.
What were how big did you build those companies?
They were all pretty small. The first one had 12 or 13 engineers.
Okay.
And the next one was 20, 25 folks in the company. And then this company is currently about 46. So I enjoy being in the early stages, of companies. It's a lot of fun. It's not easy. It's definitely not boring.
What is it about starting a company that really gets you excited or keeps you motivated?
Well, you're always learning, expanding quickly. It feels good. I think certain folks are attuned to it, to be in that undefined space. I mean, everywhere you go is kind of new, which means you're also getting, it's like going through the woods without any path. You're getting scratched up and hit in the face with branch and all that stuff. But it's never boring, And so, it just goes back to I really have a passion or, as I said, an obsession to do things that haven't been done before that are different, uniquely different.
Is that a trait that you've had all your life? Is that something that you remember going back to being, younger, childhood or something your family would point to?
Yeah, it's always, I think I always tell the story. My first electrical circuit was just a ball of wire that I found in the basement. I twisted together and I brought it up to my mom, which I have to give her a lot of credit for trust. And I just had her plug it in and it was nighttime. So she plugged it in and it was a big blue flash and all the lights went out in the house. And she was just, I remember just sitting there in the dark. She goes, "Don't tell your father." That's what I remember from it.
Where did you get the idea for that?
for twisting the wires together. I actually was influenced by, interestingly enough, a woman. I mean, my aunt was a very early engineer. She was one of the founders of the Society of Women Engineers, which is a huge organization now. And she always brought things to me when I was a child that were broken and just threw them in my room and said, can you fix this for me? I thought I was doing her a big favor. She was just challenging me to understand the equipment. And at that time, there was very little what they call safety agency approvals, like what we know as Underwriters Laboratory, or the little marks on the back. So back then, things would just catch on fire. Like if something was wrong with them, they would just burn, and they were, the materials were flammable. There was no real fusing or controls. Yeah, it was fun. Yeah, that's how I got influenced way back then as a child.
Did you end up watching any of the biographies of like Edison or Tesla and just how, some of the inspired by some of the early inventors as well?
Oh, yeah, of course. Yeah, going all the way back to there's a great book called Devil in the White City. It's about the Chicago World's Fair. It was 1897, I think, almost at the end of the 1800s. But that's where it was kind of all decided. It was such a great book. It talked about, Edison and basically Westinghouse and Edison were fighting for, distribution. And this is a lot like that. This kind of has aspects of, Edison had lower voltage that was considered safe, DC power, and Tesla had high voltage that could go long distances. And so Edison lost that contract because of the amount of copper. It was low voltage. So to get it across the park, the fairgrounds, it required a huge amount of copper and expense. So that's kind of where all that happened. So Westinghouse won that contract, and that went on. From there, they went on and did the Niagara Falls generation plant. And that's where it really momentum took off. But back then, there wasn't any things like we have today. There wasn't power electronics or semiconductors, digital signal processing. So, the invention that we were talking about today is sort of a fusion of all those things. It has the high voltage characteristics of Tesla, but the safety aspects of Edison in a digital format. So we call it a third form, AC and then DC. We call this DE, which is, digital electricity.
Yeah, it's a fascinating story. I've always been fascinated by Nikola Tesla because I feel like there was something about what he was doing that was so way ahead of his time, and he unfortunately ended penniless, and then he didn't really get to. He was so ahead of his time, he wasn't able to capitalize, and Edison was the better businessman, and was able to capitalize on his inventions. But it's fascinating to think about what's possible and what was possible then. How far ahead of the curve someone like Tesla was. And now we're starting to see, and some of the stuff we'll be talking about today, how some of that stuff comes to fruition. But I'm always fascinated to think about, how people are inspired, what inspires people, like how they come up with these ideas. And I don't know how it is for you, if it's just a process of constant iteration and tweaking and making things better, or if in fact it is truly just flashes of inspiration from some other field that, really allow you to think differently about a problem you're trying to solve.
Yeah, for me, it's just a lot of work. It's a lot of hard work. Yeah, I wouldn't say I'm in the category of what they call the flash of genius or flash of inspiration. It's mainly about looking at problems and finding sort of an unthought of way to solve a problem that hasn't been thought of before, but sort of starting from this problem perspective. And this invention that we call digital electricity really came way back from that first business where we were working with the first batteries. When they came out at that time, lithium-ion batteries were exotically expensive and dangerous. They were volatile.
Yeah, they were catching fire.
Yeah. So we were trying to figure out how to, our work back then was how to create arrays of batteries, right? And I mean, that's a whole nother story. Some of the work we did became what is the Tesla battery today, which is a massive redundant array of cells. So back then we were working with a company called AC Propulsion, which was this little tiny company that never got a lot of credit for all the great things that happened in electric vehicle development, but they did a lot of it. Alan Cacconi was the principal there. and these other guys. There won't be enough time to cover that great story, but those guys, whenever I get a chance to give credit, I always try to call out AC Propulsion because of all the work they did. They had a vehicle called the T0, which became, as you might know, Elon Musk wasn't the founder, the original founder of Tesla. I think it was Martin Eberhard is the name of the guy, if I recall correctly. But we were working with that little company, AC Propulsion, and on that project, that redundant cell technology became my second business. But this invention was trying to figure out how to make electricity safe to touch, even at high voltage, so that you could do things like energize roadways and garage floors and things like that. That was the original sort of problem to be solved with this invention. We'll hopefully get back to that as time goes on. It wasn't our first market when we actually launched.
You mentioned obviously that company, but were there other folks along the way that you partnered with, that mentored you, or that you had good relationships with that helped you, and that you can credit for where you are now?
Yeah, for sure. Yeah, like Stanford Orshinsky from Ovonics, who he's the inventor. Well, he's passed now, but the inventor of the nickel metal hydride battery. That technology is in the Prius now. But he was a very colorful character that worked in early electric vehicle development. And he always showed, like in the front office as he came into his building, their first battery. He worked with his wife, but the first battery was made in a toilet paper roll. Kind of the springy thing, not the cardboard thing, but the springy thing that goes in the wall. That they built their first battery with that. He was quite the character. Yeah. Tom McReady out of AeroVironment, which some of the folks from AC Propulsion came from AeroVironment. Tom Gage was out of there. Great people that were very influential to me.
So talk to me a little bit about the origin story of VoltServer, because at that point you had started and exited a couple of companies. So we're going back now, 2012. But how did the idea come about, and what was the problem you were looking to solve, or what was the opening that you saw in the industry that you're looking to fill?
Yeah, it originally started, as I mentioned, was to try to go after electric vehicle technology to allow batteries to be extended over long ranges, like on highway surfaces. And we did a lot of work that said if you could effectively charge on the highway and you only had a 100-mile range on the vehicle, you could go almost anywhere in the country without too much trouble. You just had to get back to a highway to recharge. And then it's a little bit difficult because there's nothing like digital electricity. There's nothing out there where you can touch wires and it knows the difference between you and a vacuum cleaner or something, right? If you expose the power wires, you just look like another load on the power wires. There's something called a ground fault interrupter, which is a separate sort of conventional device. I'm talking about the actual power conductors that go to the vacuum cleaner. And a lot of, like a vacuum cleaner today, it doesn't even have a ground wire. It's just two wires. You can't touch those with regular electricity, have the electricity know you're being electrocuted because you're drawing less power, much less than the vacuum cleaner.
Okay.
It has no way of doing it. It's dumb. AC power is, as beautiful it is from the time of Tesla, right? It still goes back to those days where they just knew how to make transformers. There's no real intelligence to AC power. And same with fire. It takes very little energy to actually start a fire. Much less than will pop the circuit breaker. So digital electricity is sending energy, these very small things that we call packets. And you can look at it like water coming out of your faucet. If it's high enough pressure, it's dangerous. And the analogy to pressure in the electrical world is voltage. That's the emotive force that moves something is voltage and electricity and pressure in, looking at things like water flow. But if you break that water into billions of little droplets, each little droplet isn't dangerous in itself. It's a small quantity of energy. Our technology does that with electricity. It breaks electricity in billions of quote droplets and then tracks that flow from one place to another. So if it goes into your body, it knows that it went to the wrong place. And that's never been done before. There's nothing out there in the world that can do that. It's uniquely new. And it's a little frustrating because once we get past that part, everybody says, oh, what are you going to do with it? But I'm like, whoa, hang on a second. This has never been done before, Now we could talk about what we can do with it, but that's how it works. And it's compatible with data. I have a bunch of it behind me on the here. So there's a transmitter unit and a receiver, and we're tracking, the transmitters are over here, and energy is coming in the back from a conventional source like AC. And those that look like computer servers are breaking it up into those packets and sending it overhead in that line over into receivers that put it all back together and power something. And in that space in between, it's pure energy. It's uniquely energy, where everything in history has been, power is just a manifestation of energy into work over time. In the space between the transmitter and the receiver, it's never manifested into power. It stays in the energy space. And so when you touch it, it doesn't hurt you and it won't start a fire. And then it goes back to regular electricity at the end to power stuff. A lot of the stuff we power is like communications infrastructure and stadiums and, lights and controls in hotel rooms. And then indoor agriculture, as you know, is a really nice application because we put the transmitters in the electrical room back here, and then a bunch of LED lights, thousands of LED lights in these grow facilities. We're sending those packets right into the LEDs because they're naturally DC devices.
What was the response as you started to have people test this or really showing people what it is you had developed? Did you understand what the applications would be early on, or is it something where you were really, discovering yourself what it is you had created or invented and what the possible use cases for it would be?
It definitely took some iteration. I mean, the first place I went after was EVs, but it was too early even back then because the devices need to be compatible. The hard thing that we do is that at the end behind me where we convert back to regular electricity, we have to make the electricity compatible with conventional devices. So it goes back to being AC or low voltage DC. And that compatibility was tough with electric vehicles because they wanted to take up AC input, and it's hard to convert our stuff. It's expensive to convert it back to AC. AC is the thing we're trying to avoid. And then at the very end, we have to put a big box here to invert it back to AC.
Yeah.
So it wasn't our first sweet spot, where the communications market already uses DC. Like the standard in a stadium or a big building is 48 volts DC. And so it was much easier for us to get into that market first. So we started there, and then we're just coming back to doing electric vehicles after all these years that we've been in operation now for about 9 years since we had our first round of funding.
And how do you describe it? Did you come up with that term digital electricity right away, or is that something over time that you thought? Because obviously it's a really sexy way to sell what it is that you do that's different than what people might think of normally.
Yeah, that was my partner, Dan Lowe, the business officer for the company. The technical term or the protocol is called packet energy transfer. He's like, no, too technical. Is that it doesn't roll off the tongue. It's a digital electricity is more sort of marketable.
Yeah.
And so it was his idea to do digital electricity. And it is a much easier word to pronounce. I should say though, the industry, we're the inventors of the technology, but there's other folks that are starting to get into the business. And the industry calls fault managed power for the new standards that are being developed around digital electricity. So we operate, all our stuff is certified. It's what they call listed technology. But the industry, as they got involved, they wanted to build sort of a custom standard and custom code section in the National Electric Code for it. And that's kind of what's going on now. And that turns sort of a smaller bridge into a highway for the industry. So that's kind of a big thing that's happening right now.
What's been the response from the associations and the industries that provide, these, you talk about you turn over any electrical appliance and it's got the stamp on it, right? That most people know. So, and these have been associations that have been around for decades. And it feels like this is something that's new to them. And it's innovation in a space that probably doesn't see a lot of innovation, over decades. So I'm wondering what those conversations with folks that create these standards have been like.
Yeah, the standards they're being developed by folks that want to create digital electricity infrastructure or, ecosystem folks that want to install it or service it, all that kind of stuff, or produce software. I think the appliance industry is a really good subject for, full displacement. in buildings, things like refrigerators and stoves and things like that. We don't want to convert back to AC and devices that big. I think the appliance manufacturers are okay. They're not resistive in any way, but they just, they need to see tens of thousands of unit sales before they're interested in converting. The indoor agriculture space was different because it's already Wild West. Vertical farming is a Wild West environment. Everybody's thinking of all the new ideas now. We're not pushing against infrastructure. So that, we work with lighting manufacturers and they're perfectly compatible with us in terms of, hey, let's try something new. There's no industry resistance. But in the big building applications, as you know, there's things that are called value networks, which are all the web of connections between all the folks that are working in that more conventional industry that might be disrupted or changed. They will adapt over time, but it's always resistive at first. So that's something that takes a lot of education, ecosystem development, marketing. Yeah, it's a multi-decade effort. But yeah, we see this type of electricity just being the next thing in electricity that will displace full AC infrastructure in buildings and probably cities. It'll take a while before it goes to, long distance transmission and things like that.
So talk a little bit about your early forays into the vertical farming world. Was that someone from the company that suggested it, or how did you guys get started or get your foot in the door there?
Well, you met my brother out at the Ag Show, and we've been working together for a long time. Like, he's an agriculture economist, a professor. And so we've been writing papers together at the sort of nexus of energy and agriculture and things like that. We looked at papers for turning corn into ethanol and all the, the pluses and minuses of all those different bigger infrastructure changes, industry changes. And this area of indoor agriculture was a paper we originally wrote, I think it was 7 or 8 years ago now, about how the cost of LEDs were coming down and efficiency was going up with the LED manufacturing. And if you go to areas in the country like Canada, in northern latitudes, my brother is a professor at Laval University up there. The cost of heating a greenhouse for very little sun that you actually get in that part of the country, there's a trade-off where we actually saw that within 4 or 5 years, it wouldn't make sense anymore to have greenhouses in those latitudes. And, that was kind of what started all of this, was these two big things coming together. VoltServer had a better way to deliver the electricity, which is a huge part of indoor farming. And then with the LED technology migrating to lower costs and more flexibility, it was sort of as they call, like a perfect storm event that pointed to that direction. Because we have intellectual property here at VoltServer about sending, as I mentioned, we send those packets directly into the LED array. And so we remove the drivers, that on a conventional grow light, there'll be an AC to DC conversion device. So they call it a driver that sits on the light. And it's the highest failure point for the light. That's the thing that fails first. So with digital electricity, we strip all that stuff off. We eliminate thousands of those drivers and we centralize into cabinets like this that look like server cabinets in the electrical room. And the packets go out into the grow area. But it's also data in there, right? So digital electricity is, the safety aspects and energy are combined with data packets. So there's full control in the grow room.
What's been the initial reaction? I mean, the way you describe it, I imagine LED manufacturers are really chomping at the bit to test this out and to implement it and to really partner with you or figure out how to design or the new iterations of their LEDs, have them be compatible with what you're developing. And I imagine they're pretty excited at that opportunity. Yeah,
right now we have 6 or 7 of them that have designed the lights. Some of them are deployed now in the field, and others are on our test benches here. So we work together. We send them gear, and they send us fixtures, and we test them for compatibility. So I think there's a pretty good movement in the industry to move away from all those little drivers that are in the grow room to centralized architectures. And so the timing is just right. Like it was an amazing conference, the one that you were at and we were at. Just you could see those factors all coming together. There was a time, when we went to ag shows early on, that people didn't believe you could grow food with LEDs. There was a huge, I think it was only maybe 6 years ago where maybe 70% of growers grew with high pressure sodiums, the big hot bulbs in the ceiling. And they just simply didn't believe that you could grow with LEDs. And, that's it. That's infrastructure, that you have embedded paradigms of how people see things working. It takes a while to bring it over.
So obviously there's a direct correlation between what you're providing with digital electricity and efficiency and output with LEDs. Are there other facets or aspects of vertical farming not related to LED, any of the equipment where VoltServer could also allow for improvements in functionality or cost?
Yeah, because we have that ability to move energy and data, the things like programmable logic controller boxes, all the controls out there, temperature sensing and controlling, irrigation systems and all of that. All those things have control aspects. So, in the grow room, we're displacing all of the conventional power distribution and conventional communications lines and going to sort of one common system. We call that digital convergence. It repeats itself in buildings, for example. In buildings, you have electrical infrastructure where a big conduit's going up through the vertically in the building. And then you have communications infrastructure. And it's not just the equipment, but it's also the skill sets and the people and the software, right? So digital convergence is you have one common platform that has energy and data in it and one common software, protocol, like an IP protocol.
Yeah, because the way you describe it, it's almost sounds like a giga Ethernet connection that's facilitating the communication and the transmission. Instead of energy, it's electricity, which is fascinating to think about.
Yeah. That digital transformation is happening everywhere, right? Like some folks call it IoT. So buildings and factories and farms and all of that, they're digitally transforming to have they're basically big computers taking in inputs, processing. And that requires the movement of energy and data. And the AC electricity it hasn't evolved in 150 years. It's still the same. So this is just part of that evolution. We're one component in the evolution of society, towards this digital format, digital transformation.
I'm wondering, as with any disruptive technology in an industry that's been around for centuries, if there's an aspect of like awakening a sleeping giant, and there's, you talk about all these technologies and services that will be displaced, like I think you talked about the converter boxes or anything that's in the way of, that's not needed right now because of what VoltServer is doing. And so I'm wondering if there's any rumblings about folks that have been established in the space for a long time hearing what you guys are up to.
Yeah. We're in 1,000 buildings now. So yeah, it's out there. And the effort that you saw when I talked about the standardization, the National Electric Code, that was all of that happened there. Because there was folks that were in the development groups for standards development that were there to see, to disrupt us. And other folks, and I think that might have been what started it all. Like, folks that said, what is this crazy stuff? You guys should look at this because there's some funny business going on over there, But I think as people looked at it, they brought in scientists, right? On any one time, we have 3 or 4 PhDs in these standards groups analysis sessions. And they started thinking, wow, okay, this is really different. And as that happened, now we went from a point of view where we had people that were trying to like knock us off a ledge to competitors that want to come in and jump in. They're like, oh yeah, this does look interesting. And that started tilting over time, where now the momentum is a bunch of folks that really see it as a new industry. And so our job is to cooperate where we can, because the pie gets bigger, right? It actually will help us because other competitors give second sources. We're big building owners and big projects. They don't want to be stuck with a unique company. So there's good aspects to it. Our job now is just to stay at the front. We're the first movers in the industry. So from a management perspective, we want to stay in that position.
Yeah, it makes a lot of sense. It definitely would seem to have a target on you now that everyone has seen this new industry that's rising. But I think you definitely have first mover status. Are there patents associated with the technology you've created as well?
Yeah, many patents. Now, I want to throw one thing in, is that the electricians community, they've been incredibly professional. Like a lot of folks made sort of jokes around the electricians are going to come around and, would steal pipes or something like that. For one thing, a lot of them are geeks like us. They want to see the next thing. And the whole concept is kind of silly. Like digital electricity is a new type of tool for electricians. And it's almost like an electrician saying, hey, if you give me a better wrench, I'm not going to use that wrench because, I want to spend more labor time turning screws. No, they're a business like any other business. They look for new ways, and they are also enamored with new technology. So they've been gentlemen. The whole industry that, from my exposure, has been nothing but good exposure with the electricians community. So most of our systems they're installed by electrician firms. So I just wanted to throw.
Yeah, that's nice of you to shout them out as well, because that is true. They are the front lines, and that makes me think of another question. Are you seeing applications in housing and buildings yet, or is it still too early? Or this would seem like you talk about IoT, like house of the future. If you're going to have something that's future forward and somewhat future proof, this would seem like the technology to be using.
Yeah, depending on the flavor of the current digital electricity is what's called a class 2 power circuit. And that has its pathway, as I mentioned, the bridge in the National Electric Code. That can install in a lot of places now. The big bridge that we're building is right now focused on commercial and also apartment buildings, like MDUs, as they call it. That there wasn't enough time in this current code, the 2023 electric code, to get in residential. People wanted to understand it a bit more before they built the big bridge into residential uses. But I think that will come, every couple of years, the code cycle goes through. And so I think residential will come after folks get comfortable with it in a big way in commercial.
What are some of the applications that you can anticipate? Obviously you're seeing how folks are applying the technology now, and we talked about LEDs, and we talked about some of the things that where people are putting it into active use today. But sometimes you would probably be surprised if you look forward 5 years and saying, wow, I didn't realize that this technology could be used for this. And so just kind of have your crystal ball in front of you. Can you think of applications that we may not even be able to dream about, but because of the nature of the technology, it would lend itself well to exploration in other industries?
Yeah, I have a couple easy ones, but going to what you said, it is a new digital electricity is a type of platform that industries form around. And that's kind of the fun of it, is that you don't know what happens. All of a sudden, you see all these new things happen. Communication is the same way. When you talk about 5G, everybody wonders, oh, we have all this bandwidth. What are we going to do with it? We don't have anything to do with it. All of a sudden, something happens. It's, that society expands exponentially from a technology standpoint. It's because of all those unknown things. But for the easy ones for me that I see for us coming up next is probably things like data centers and electric vehicle charging infrastructure, because it installs very easy at high power levels, and it can go in, like you can slot it into concrete where normally you have to dig down way deep under the ground to install electricity. But this stuff, because it's inherently safe, you don't need all those, like conduit, you're seeing on the ceiling, those metal pipes. Conventional electricity is inherently dangerous. So it's like a wild animal. And a lot of the work goes into containing that animal, where you can see in the green wires here, digital electricity wires, there's no metal cage around it. The cages make it expensive, like containing a lion is much more expensive than a house cat. So that's the differential that makes it, from an economic standpoint, that makes it sell. Once you have that sort of flexibility, you things like, if you look like building infrastructure, being able to use integrated building components like, floor baseboards that have integrated electricity, or even things like those 3D printed homes where, they could print wires with this stuff inside the concrete instead of running conventional wire, and that's the kind of stuff you can do. It doesn't have the ability to start fires anymore if you make a mistake or hurt people,
wow,
even when it's carrying really high power.
Yeah, I think if we have this conversation in 2 to 3 years, I think we would be pleasantly surprised by some of the innovation that's happened in this space, and the people who have been able to think outside of the box because they don't have the constraints of trying to tame this, this wild animal that is electricity and live power, and the flexibility you'll have. This vision we have of driving cars on the highway and having them recharge as they're driving along the highway, and quick recharging of electric vehicles. It's something that, we've dreamed about as a future, but I think with now you can see the how that's possible with technology like this.
Yeah, that's right.
I'm curious what your thoughts are about what's been happening in the vertical farming space in indoor ag, and just, separate from the functionality and the efficiencies you're providing with VoltServer. What's been your perspective, not traditionally coming from this industry, how you've seen it, and the opportunities that you're seeing in the industry itself, because it itself is growing at a pretty fast pace as well.
Yeah, I mean, we're a big believer in vertical farming. It's transformational. As you know, almost everything about it is good. I mean, most fertilizer that gets distributed into a field disappears into the ground and shows up in groundwater, and then that ends up causing, fish kills and dead zones, and not to mention pesticides. Moving on to that, right? Like, different pesticides get involved with groundwater. You have all sorts of side effects from not just human effects from eating the stuff, but the pesticides getting into water streams and the ecosystem. And then you have water use. If you throw that on, like indoor farming or vertical farming recycles water, and land use is much less. So it all comes down to where we are, which is energy. The sort of black eye in vertical farming is the electricity use. And if that electricity is created using carbon-based sources, it's not good. It's burning is creating a lot more carbon. So I think the big movement is going to be things like, as we move towards carbon-free energy sources. And if you go to Canada, like, one of our cannabis installations in Canada is hydropower. So it's pretty good up there in terms of renewable. And we have a big Florida installation, Hardy Fresh, that is solar based. So they have the strangest thing you can imagine. You have this closed warehouse like building that no sun can get into it. They have a whole huge solar array outside creating electricity. It's wild to see, but that was to get the carbon content down on the facility. Because the reason they do that, the reason why that's so weird, is because the sun is not free. It's not cheap as people imagine it. The sun is very expensive to manage. And in a greenhouse, the sun gets in the greenhouse, and in the summer it gets too hot. And then you open the windows, the bugs get in. It causes all sorts of insecurity on the part of the farmer of not knowing what's going to happen next. And so that drove to having better control, very, very controlled food production year round, right? And during COVID-19, it accelerated because people got threatened by food security during COVID-19. There was an increased focus on health. And another big one was because outdoor farming uses migrant labor. With the borders closing down, it caused huge disruptions in food supply, where the indoor farms, like the Hardy Fresh facility I was telling you about, they have regular employees that come in every day, right? And they get paid to come in on a regular basis. So it's stable. So it wasn't disrupted by the COVID event as a lot of the other sources for food.
Yeah, it's been an interesting time for me to launch the show, because I launched in the middle of COVID, and it sort of brought an awareness to me learning about the industry, but also realizing the importance of local access to fresh food, the concept of food deserts, and just how much the supply chain was really affected by what happened during COVID, and an awareness to people who may not have understood, just how far your produce needs to travel sometimes to get to your table. And it's one of those little known secrets, dirty little secrets of farming itself, which I think have come to light. And so any opportunities to improve it from an efficient standpoint or cost standpoint are certainly going to be welcome. And to your point, yes, the one little dark mark on vertical farming is the fact that it is energy intensive, and this helps to solve that problem. So I think I would imagine that the technology is being met with open arms from a lot of folks in the vertical farming industry.
Yeah, it's really exciting for us, for sure.
A couple of questions as we wrap up. What's a hard question you've had to ask yourself recently?
A lot for us is about our path to scale from a business. A lot of I love the technical side of the business, but I'm also the CEO. It means that from a startup perspective, it really kind of hit me, it means chief executive officer. And that means paper. It's a lot of office work, So a lot of my worries and challenges are about scaling. There's so many different markets. Like electricity is generic. Which makes it beautiful. That's the abstraction that it provides, but it means it can go into just about anywhere, and it is. So a lot of my work is strategic on how to grow the company quickly, but not too quickly, so we burn the company out. All that kind of stuff is the day-to-day stuff that are the challenges for me. But I love the work. I mean, what am I going to do? How can I complain? Somebody should lightning bolt.
Given the audience and the fact that this is focused on companies, people who are interested in the vertical farming industry, and people who work in the industry itself, is there an ask that you have for this audience?
Yeah, I think the industry is evolving. I venture to say a lot of it started from cannabis, and it started from folks that were in the black market, and it's very hard to cooperate. And I think the big challenge for everyone in vertical farming now is sort of a scientific approach. It's one of the most interesting spaces I've ever worked in, this sort of cross section of biology and technology and all of that, and purpose, right? But it's very easy to get off track because things are changing in 9 different ways all the time. And vertical farming, what I find to be one of the most unique things about it is that, folks talk about how corn used to be this big, when it was first in the wild. And over hundreds of years, people, they cultivated it into what it is now. That's going to accelerate now because you could never hold things constant before like you can in vertical farming. Now you can hold all the, the temperature, the humidity, right? Light levels, right? Things that get into the room like insects can be controlled now. And then you could tweak one thing and see what's going to happen. And that's going to mean it's going to be an exponential increase in the amount of research and findings that we have in the industry because of that. It's really, really exciting, but folks need to cooperate, share research and stuff like that. And we're the same, we're commercial. So you want to hide your secrets, but then cooperation has always been the way that's made us successful as a society. So I'm really excited to see how it plays out.
Yeah, that's an important thing to highlight, and I'm glad you mentioned it because it's something that I've seen, and in the course of these conversations, it's been consistent that, to a person that's come on the show, just talking about the importance of working together, developing open standards, and I think it's such a young industry that there are a lot of opportunities to learn from each other, and so I'm glad you continue to bring that up. Can you talk a little bit about the roadmap, what you have planned out to the extent that you can talk about anything that's, 3 years is probably too long in this industry. So for the next 12 months, what has you excited about what you're working on at VoltServer?
Yeah, the big releases coming up for us is we have a new, more optimized transmitter unit that is more power dense and lower cost for the customer. Software development for managing the grow areas and things like that. And probably what we call inline communications, which is more advancements in that communication component of the pack. I talk about this energy packet thing as what's called an energy component and a data component. And we're always trying to pack more functionality in moving data and the offset of moving energy and data at the same time. So we're going to be working on a lot of sensors and controls and sort of APIs for ecosystem partners. That's the big things going on with ag.
Oh, well, Steve, I appreciate you making time to come on the show. And I think it was really intriguing for me when I saw it at the conference and had an opportunity to chat with your brother about it and just learn more about it. And it just feels like it's something that's groundbreaking and innovative. And I want to applaud you and the team for all the innovations you've created in this space and for being pioneers in this creation of digital electricity, which for the vertical farming industry, I think is going to be something that it's needed for it to grow and to move and to sort of mature into its next phase. So it's going to be exciting to see what's on the horizon. If folks want to learn more, they can go to voltserver.com. Any other place you want to send them if they want to connect with you or the team?
Oh, no, that's great. They'll find everything there.
Okay. Well, thanks again for your time. It was really interesting to hear the backstory and the origin story of how everything got started. So I appreciate you sharing that.
Thanks, Harry. It was a pleasure talking to you.
Thanks again to Stephen for coming on the show and sharing his story. As always, I appreciate the time that my guests spend with me and I don't take that lightly. And I appreciate you for listening and all the feedback we've been getting on the show. Don't forget, leave us a rating and review at ratethispodcast.com/VFP if you haven't done so already. I love reading those out on future episodes. Special thanks to our Season 5 title sponsor, Cultivated. If you are looking for a vertical farm and don't know where to start or which technology would suit your needs, reach out to them today. Best of all, their service is free because they work on behalf of their partners. Learn more at cultivated.com, and that's spelled CULTIVATD.com. Just leave out that last E. If you're hearing this in the last week of June 2022, it's likely that I'm on a plane to Indoor AgTech NYC, indooragtechnyc.com. Looking forward to meeting a lot of previous guests and new friends at the conference in New York City in Brooklyn. Podcast production and marketing provided by Fullcast. Learn more at fullcast.co about how a podcast may be helpful for your brand and business. Speaking of conferences, tune in next week for my conversation with Brian Sullivan, the CEO of Indoor AgCon. Thanks for all you do to support the show. And until we meet again, here's to your health.
Thanks for listening. To read the full show notes for this episode, which includes any links mentioned in the episode, as well as a full show transcription, visit verticalfarmingpodcast.com. There, you can sign up for our email list to be notified when new episodes are published.